for the second part of this lesson, graphing exponential functions. First off, let's take a look at the properties of the basic exponential function, any base raised to the x. Okay, essentially, we have f of x is equal to a times b raised to the x, where b is the base, x is the exponent. A is your vertical stretch. Remember that I can also have a to the b x minus h, there's your right-left shift, plus k, that's your up-down shift. Okay, we really don't do horizontal stretches and compresses on powers like this. That's just a little crazy. All right, so the domain is the set of all real numbers. I can put any real number in here, from negative to positive to even 0. The range is the set of positive real numbers. When I'm just looking at the parent function, okay, the parent function is f of x or y, it doesn't really matter, is equal to b to the x. Okay, looking at the parent function, the range is a set of all positive real numbers, or y greater than 0. Or we could do from 0 to positive infinity. Any of those can be written as the range. The y-intercept of the graph is 1. Why? Because any base, it doesn't matter what it is, to the 0 power is equal to 1. I don't care what b is. If I raise any value to the 0 power, I'm going to get 1. Now, how would this change? If I add or subtract something, then I would take my graph and I would move it up and I would move it down. Right? The x-axis is an asymptote of the graph. Y equals 0 is a horizontal asymptote. Okay? Now, how does this change? Well, if I add or subtract, it's going to go up or down. So y equals k is actually the horizontal asymptote. Now, when you graph this, you're really graphing 0, 1 for all of them. And then when you come out and if x is 1, then y must be b, because b to the 1 is b. Those are the 2 points that you graph, and then you're asymptotic and you go up. If you raise it left or right, then you raise it left or right. If you move it if you raise it up or down, then you move these 2 points up or down. If you move them left or right, you go left or right. But these are the 2 points that you work with, and this is kind of the curve. Now, let's take a look. Exponential decay, decreasing function. Y is equal to 1/2 raised to the x. When my base is a fraction, the absolute value is between 0 and 1, I'm going to go down, because as I take a fraction to a higher and higher order, my y value gets smaller and smaller and smaller. 1/2 squared is 1/4. 1/2 cubed is 1/8. It just keeps getting tinier and tinier and tinier. We call this exponential decay. This also happens when y is equal to 2 to the negative x, because these are the same things. Okay? And when I graph it, I can just look at this. I just know that when the exponent is negative, it's going to be decay. Exponential growth is when the base itself is greater than 1. And that's the absolute value. That means there's no reflection. We're not going to talk about reflections right now, but if there's no reflection over the x-axis, then it's growth. Because if I put in a 0, 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 to the negative 1 is 1/2. And so on. And I've got my curve. Positive exponent, growth. Negative exponent, decay. And a negative exponent also causes that base to be 1/, or a fraction between 0 and 1. Note, a base greater than 1 raised to a negative exponent would be decay. Now, Let's take a quick look at some graphs of exponential functions. Focus on the basic shape and the transformations that occur. If you remember the basic shape, then if I have y equals 2 to the x, and I want y equals negative 2 raised to the x, notice that's not in parentheses, that's negative 1 times, okay? This is different, whoops, from this. That's a different graph, so we're not doing that. This is just a negative on the outside, so therefore it's a reflection over the x-axis. So I simply take 1 above, 1 below, 2 above, 2 below, and then I'm going to graph it, and it's going to go down forever instead of up forever. Here, the range, okay, is going to be from negative infinity to 0. And I've got to do little parentheses. There we go, because it goes forever down. It comes up, but it's never going to hit 0. Domain is still negative infinity to positive infinity. If we look at a vertical stretch by 5, okay, notice that it's y is equal to 5 times the quantity 2 to the x. So I'm doing the exponential, and then I'm multiplying it by 5. So I'm just taking whatever my answer is and making it 5 times as great. So it's a vertical stretch of 5. So 1 goes to 5, 2 goes to 10. Where would 4 go? All the way up to 20. All right? So notice here's the graph. We're just using the transformations that we did before. Take our x values, get our y values in our parent function, multiply those y values by 5, and I get my new graph. Here, x minus 3. This means I'm going to go right 3. So again, I take my parent function, I put in 0 and 1, and I get out 1 and 2. I'm going to move everything to the right 3. So 0 plus 3 is equal to 3, and I'm going to just get 1. And then 1 plus 3 is equal to 4. Boom. Because notice that if I plug a 3 in, 3 minus 3 is 0. 2 to the 0 is 1. If I plug in a 4, 4 minus 3 is 1. 2 to the 1 is 2. So I simply have taken and shifted each one of these points to the right. The shape of the graph is the same. The range is the same. The domain is the same. It's just been moved to the right. I still have a horizontal asymptote at y equals 0. Now, what happens when I move up or down? Well, now I'm going to take my y values and add 3 to my y values because I'm moving this up 3. 2 to the x plus 3. Notice I took each point and I raised it 3. And I also took my horizontal asymptote, which was y equals 0. It is now y equals 3. So when I graph this, this curve should come down but not touch or go below y equals 3. And we're just using these transformations are the same thing you did in Unit 2. Decreasing function. Okay, y equals 2 to the x, y equals 1/2 to the x. Remember that 1/2 to the x is the same thing as 2 to the negative x. Same thing, and it just reflects itself over the y-axis. Okay? Remember, up here it's a horizontal reflection, so it goes over the y-axis. Decreasing down to. I take my function and I move it down to y equals negative 2 is the horizontal asymptote. A lot of the things that you might be asked on tests is especially what is the transformation, describe the transformation, or maybe pick out a graph from a bunch of graphs. Okay, so this isn't too bad. Now, that's going to end the graphing exponential functions. Again, everything you're going to be asked to do is going to be from a transformational approach. Simply graph, do a quick sketch of the original. And for the most part, it's going to be y equals 2 to the x. Could be y equals 3 to the x. You get much past that on something like a test, and you need a huge graph, and that just gets awkward. So you're good to go.